Welcome back. In today's lesson, we're going to be doing our first case study where we'll be implementing all of the ideas we've talked about already. Now this case study is going to be an employee case study. What this means is that we're going to be creating a program that will model an employee. So the most important thing to know is when we do a case study like this, there's always going to be multiple ways to do it. However, most of the time, the way we're going to do it together tends to be the most efficient way and the best way to practice what we've used so far. We're going to want to practice what we've been talking about in practical applications, since in the real world, you have to write real programs. So the first step of this is going to be to make sure we create a new class file. Now you could even make a new folder for it. You could even make a new project for this. I'm not going to. I'm going to group all of our stuff together so that each project will be for each large group of ideas. So since the employee class is just going to be implementing what we've talked about so far, I'm going to keep it inside the same project as Hello World. So we're going to call the class file employee. Now remember, this class file, to practice our naming, has to have the first letter capitalized, and if there were multiple words, which there aren't, then we would need to make sure that we left the ensuing words with the first letter capitalized and every other letter lowercase. Now this is enough, so we're going to hit finish, and then we're going to add in our main method. Now you might be wondering, why do I always tab in for the main method? Or why is there always that indent? This is, again, for readability. You'll start to notice that a lot of the stuff we do tends to be for readability. This is because we want to make sure that when somebody's reading through our code, it looks fine right now, but later on when we get into multiple methods and multiple class files, it becomes extremely important that we indent properly. So follow the same indentation procedure I'm doing, because it'll make sure that our code is extremely readable to both us and other people. So now that we've done this, we can start to think about the employee program. Whenever we build a program like this, where we're modeling something else, we're going to want to know what are we modeling of that other object, how much in depth, and what's the general scale of this. So in this case, all the scale is we're just going to be modeling one group of employees. We can do 3 employees in this case, since that's a nice number. It's not going to be in any larger context. It's not like we're going to do this as a part of modeling an entire workspace or anything. We're just going to be modeling 3 employees. They're going to have a couple of attributes. They're going to have a name, an age, an hourly wage, and hours worked. We're going to want to be able to take in this input from the user and calculate and output their names, ages, and earnings for the time frame for each person. So this actually is a fairly in-depth program for the stuff we talked about, but it'll hopefully show you that even if we're just a little bit in, we've talked about a lot of very useful stuff. Now in theory, this should be a pretty easy program. But the most important thing is that we have to practice, because we'll make syntax errors, we'll make logic errors. That's alright, but the more we practice, the less likely that is to happen. So first of all, we know that we need a name, an age, an hourly wage, and an hours worked. So let's put that at the top. This is something that you can choose to do if you want. List out your requirements on the top of your program. That way you make sure that you always have all of them by the time you finish up your program. So in this case, let's just make a nice little quick algorithm. We won't be doing this for every program, but for the first one, it's nice to have a very in-depth process. In the future, you can do this on your own. So we're going to say that the biggest ideas: take in input for name, age, hourly wage, and hours worked, 3 employees, and we have to be able to separate out these employees, so we have to make sure they're distinct entities. After that, we have to make sure we know what we're outputting. So, output the total earnings for the time frame. So earnings, names, and ages. We're outputting the name and ages because we want to make sure that some of the stuff the user puts in, they should be reminded of again, because we're not going to be able to differentiate it too much. So we want to make sure that the user has some information. That way, when we give them back the name, they can clearly tell which employee value of outputted earnings corresponds to that name, or to that employee, if this was a real program. So now that we've done that at the top, we have a checklist that we can always keep referring back to. Now hopefully you remember that whenever we need to take input, we need to make sure that we import the appropriate classes. In this case, we have to import the scanner class. However, in this example, we're also going to be using the random class. So the most efficient way to do this is going to be to use a wildcard import. even if it's just 2 classes, it's a nice little thing to practice. So we're going to say import java.util, but remember, after this we can put in our asterisk because we're going to be importing 2 classes from that package. Now that we have that, we can start to get into the actual classes themselves. So remember, the first thing we have to do is we have to instantiate the random and the scanner classes. So to do that, we're going to say scanner, and if you recall, we always call our scanner variable input is equal to a new scanner, and then we have to put in inside here system.in. Now if you don't remember this, you can refer back to that old lecture where we talked about the taking input from the user, but the system.in just refers to the fact that we're taking input from the user's keyboard. And in this case, we are both the user and the developer, so we can test our own program. Now, we have this, but we also need to be able to instantiate that random class. Hopefully you remember how to do that. And we just say random, and we give it a name. In this case, we're going to call it rand1. That's what I'll tend to do. And that's going to be equal to a new random. And this time, we don't need a seed, so we're not going to provide a value inside those parentheses. After that, we can get started on getting those values from the user. So there's multiple ways to do this. A couple of schools of thought here. You have two big ways to do it, in that you can either ask the user to input the values all together. So you could say input all names, then input all ages, then input all hourly wages, then import all hourly hours worked. Or you could say for the first person, you could say for first employee, put in name, age, hourly wage, and hours worked. Or you could do it so that you say put in hourly, you say for first employee put in name, then for second employee put in age, then for third employee put in hourly wage, then for and so on and so forth. You keep going so that for each variable you have a specific prompt. You don't have to do it this way, and the most efficient way is going to be to group it by employee. The way you can definitely figure this out is by saying what's the unit here. In our case, the unit isn't names. It's not like we're going by each name. We care about individual employees. Therefore, we want to make sure that we keep all of the employees' data together, so we ask for for one employee's data in one space. So the way we're going to do this is we're going to say system.out.println, and then we say, please enter the data for name, age, hourly wage, and hours worked. Now, it's an important note. You can actually hit enter at the end of any string, and you'll notice Eclipse will always add in a plus and the new quotation marks. This is because, in theory, you have to make sure that if you hit that enter in between the lines, it's actually not the same thing. Hitting enter here is a different expression because if you didn't have this plus and the next string, then the way this would work is it would be saying, please enter the data for name, age, hourly wage, and hours worked, and then there would be a return, and then the next sentence. Instead, the way we want to do it is to make sure that they're all in one line, so we can leave it like this. That's just for future reference. Now we can start to get those variables actual values. Now keep in mind, this is going to be one of the most important things. Think about what your user is going to be inputting. Ages tend to be integers. They're not always, but in this case, since it's a fairly new basic program, we can assume it's an integer. Names will always be words, and words have to be stored as strings. Hourly wages and hours worked can very frequently be fractions or decimals. Therefore, we have to use floating point values, so doubles, to store those values. This is because a person could earn $7.25 an hour, and then they could work 9.5 hours. If we stored these as integers, we would get errors, or we'd have to cast, which would again cause the wrong result. So, the way we're going to do this is we're going to make sure we store the appropriate value. In addition, because we've entered it this way, we said name, age, hourly wage, and hours worked, we have to make sure that our variables line up. Because it'll work so that the first time that they enter something, that'll be stored in name. The second time they enter something, that'll be stored in age. If we mess up the order, we'll get the wrong values in each location, and therefore our calculations will be off. So, we're going to make sure we line everything up. So we're going to say string, and we can name this. We can say name1 is equal to, and then we take the input. So we say input.next line. Now it's important to note that when we say input.next line, this means you take the entire line. This is similar to the input.nextInt or input.nextDouble that we used previously. This is just the way we take in the input for a string or for a group of words. After that, we can start to deal with the age. Now the age is going to be fairly basic. We already know how to take input for an integer, and we know how to assign an integer value. So we're going to say integer age is equal to input.next int. Nothing new here, as long as you know what you're talking about with the scanner class. After that, we can now start to take the hourly wage and the hours worked. Now both of these are going to be doubles, so we can say double hourly wage, and we're going to say input.next double. And we can actually copy paste this exact same expression, and all we have to do is change the variable name, because everything else is actually going to be the same thing. We're still taking in a double, we're still using the input object, and it's still going to be stored as a double. So all we have to do is change this from hourly wage to hours worked. And now that we've done this, we now have the exact result we need. We have 4 variables that store the exact values we want. Now that we've done this, we've created everything we need for the first employee. Now, it tends to be a good idea that you make sure everything works for one group before you start expanding it out, because otherwise you're going to have to fix it for 3 employees in this case instead of just fixing it for 1. So to test it, or to make sure everything's working, we're going to create the entire program for 1 employee first, and then we'll just expand it out for 3 more, because for the remaining 3, it's going to be very, very similar. So think about what we have to output. We have to back output the name, the ages, and the earnings, as we set up here. So the names and ages we actually have already stored. We have nothing to do with those. But what we want to do is now we have to take the hourly wages and the hours worked and figure out the earnings for the week or for the time frame that we're given. So let's say we want to do this fairly simply, and we know that hourly wage times hours worked will give you your earnings. Fairly simple. So the way to do this would be to say the double, because remember, when we're multiplying 2 decimal values, we're going to get a decimal result. So we have to store it as a double. We'll say double, and then we can say, since this is going to be the earnings, we can call it earnings, because again, descriptive variable names, and that's going to be equal to hourly wage multiplied by hours worked. Now you can start to see already why it was so important to make sure we keep the same naming convention, because we already have multiple variables that look kind of similar, hourly wage and hours worked. It's very easy to confuse this, so make sure you know which variables we're talking about. Now that we've calculated the double earnings, we can actually start to move on to just output the result. We have nothing more to do. So we can say system.out.println, and then inside here, we're going to want to output this entire group of values. Now, there's a very important thing to note when we're outputting strings. You can add strings together. And hopefully you remember that when we added a number to a string, or when we outputted a number using the println function, or the println method, what that really did was it took the value that was stored in the variable, it extracted that, converted it to a string, and then output it. So we can actually combine numbers and strings to form words, or to form phrases. This is how we're going to output all the values for the employee together. So we already know how to output an employee's the text for the employee. So we can say employee 1 is, and then we would provide the age, and then we would, and we'll add that in later, but we can say is blank years old, named blank, where we would add in this name of the employee, and then earns, and then we put in a $sign where we would add in their money. Now remember, when we need to combine strings, all we have to do is use pluses. Hopefully you notice that when we hit enter, and it automatically added that plus. So in that same way, if all we need to do is add numbers and names, it's very easy. Employee 1 name is, we know the age, it's stored right here in integer age, so we can say age, and then we have to make sure we have a plus sign before and after, because what this is saying now is the string employee 1 is, combine that with the integer age, add that to the end of that string, then add that entire string to the string named, and then combine that superstring into another string with the earns blank dollars. Now remember, there is no implicit spaces here, so we always have to make sure we space our stuff out with these spaces or with these characters. Otherwise, it'll all be smushed together when we need words to break. So remember, we can add in the name. So all we have to do is say plus name. And remember, name is a string, so we don't need to do name1 is a string, so we don't need to do anything special there. and then earns a certain amount of money, and then we just add in the earnings that we calculated in the line above, in line 17. So now that we have all this, we can now get started. We can actually run our program and have our first trial run. So let's try that out. Now everything should compile correctly, and it did, so we don't have any big errors yet. Now we have all the data for name, age, hourly wage, and hours worked. Everything has to be separated by an enter. So let's have a name. We'll call ourselves Bob. We'll say Bob is 50 years old. Let's say he earns $9 an hour. And let's say he works 5 hours a week. So we now have all this information. We can say employee 1 is 50, named Bob, and earns $45. This is exactly what we want, and we can do a quick check to make sure everything's right, and it is, because 9 times 5 is 45. And then the age is right here. Now this is one of those little quirks. You can either choose to leave it like this and say employee 1 is 50, or if you want to make it more explicit, you can say employee 1 is, and then you put in the age, and then we would say years old. This is one of those things where it's up to you. It's up to you how in detail you want to go and how explicit you want everything to be. Keep in mind, for us, this is just for us to see, but when we're developing real programs, it could be for somebody across the world, and therefore that could be a little bit confusing to them. So we want to be as explicit as possible without being too long and verbose. Now you might be looking at our results and saying, well, is there a way to get this to either round off to 45 or to make it 45.00 to make it like real money? There is, and we'll talk about that later, but for now, we can ignore it since it's not a real problem. There's not a huge difference since 45.0 and 45.00 are the same thing for all practical purposes. So now we've tested our program. We know it works for this little group of data, and we know it works for one employee. That's actually very good news, because now all we have to do is just do this 2 more times. We could retype everything, and we have to keep in mind that some stuff will still stay the same, like we don't have to redeclare the input or the random objects. But all of this stuff from here to here has to be the same thing. But if you think about it, each employee is going to have the same data, we're going to ask for the same variables, and we're going to be calculating it the same way. So there's nothing wrong with saying we can copy paste this entire bit of code and then do it again for the third employee. Now this looks very confusing, you'll see all these errors. That's because all we need to do is make sure we change the values when appropriate. We have to make sure we add in a new form of each variable. So we just add 1 since now we're dealing with our second person, and then we just change all the values and it'll work correctly, because again, this is the same data. All we need to do is make sure that for each employee the data is separated out. But for all practical purposes, we're still taking the same values and they're still going to be named the same way, so we might as well copy paste and save ourselves the time. One little thing that we often forget is that we have to make sure we change our print statement. This was tailored to employee 1, so we have to make sure we change it for employee 2 and output the appropriate values. So we're going to say employee 2 this time is age, and since the variable that stores employee 2's age is called age 1, we have to make sure we substitute in all of the appropriate values, because that won't throw up an error in Eclipse. It'll actually look fine to Eclipse. But when we output it, it'll be outputting the same data for employee 1 as for employee 2, even if they have different values in reality. Now that we've done that, we can do the same thing for employee 3, and then we can actually test our program to make sure it works for all 3 employees, and make sure we're actually going to, in that case, we'll be pretty close to finishing up our program. And remember, whenever we do a naming convention like this is actually a break in the naming convention. The string, in theory, should have been named name, name1, name2, because as you can see, we're causing errors since that's the only one that's specially named. For the other ones, we didn't give a number, but only for the string we did, and therefore it's going to cause a couple of issues if we don't remember to change it actively. So now that we've done everything else, we can make sure we change the print statement, and then we can test our program and make sure everything works as it should. So we can run our program now, and we can make sure everything should compile correctly, and it did, so there's no big syntax errors. Now we can start to figure out what do we want to do for all of our test data. Our test data can be anything. For a simple program like this, we'll get more into it later on, but for now, test data is going to be a fairly simple concept. So the first thing we need to do is come up with names. So we're going to call this person Bob. We're going to say they are 50 years old, just as they were before. They work, or their hourly wage is $7.50, and let's say they work 10 hours. And then we get all the values. Now remember, because we put in 750 here, we're going to get the correct value. It's going to be 7,500. You can change that as you want. It can still be a decimal number. Remember that we have the hourly wage and hours worked as both being decimals. Now there's one more thing we have to do, because we know that it works now fine with one employee typing in the data for them, but we don't know if it works for all of the employees, and in fact it actually won't. This is because it's a quirk of the scanner class that whenever you have to take a input.next double and then follow that up with another line or another word, it'll actually just ignore that word, and it'll, for all practical purposes, it'll jump right to the next age or to the next integer value. This will cause an error because it'll try to assign the name that we're trying to type in for the employee name to the integer age, which will cause a input mismatch exception, and the program will terminate abnormally. The way we get around this, and you can see I've added this in, is to say input.next right after the print line statement. This way we can always capture the, we can get around this bug. Now the reason this bug happens, and you don't have to know this, but the reason it happens is that when you are calculating, or when you're taking those words from the next word to the next word to the next number, the way that the next double method works is it'll go, if your number is, for example, 50.5, it'll go from the 5 at the start to the 5 at the end. However, remember that there's going to be an enter in between where we put in the number and where we put in the next name. This will cause the scanner class to try to take that space, the empty white space return that we put in, and put that in as the string name. After that, it'll say, okay, the next value I'm going to assign to the integer age, and that next value is what we think is our actual string for the name. Therefore, it'll try to assign that string to the integer. So to get around this, we have to make sure we put in the input.next. So you can recompile your program if you need to. I've already done so. But it's an interesting quirk, and the reason I'm leaving it to this point is because it's one of those things where you might not only discover it until you hit the end of your program. This is a rare little quirk of Java, and so it's important to know that many times you're running your programs and you're going to have to be able to catch these on the fly. So now that we've recompiled, we can put in the same thing as we were doing before. So we can call this person John. We can give them an age. We'll call them 45 years old. We'll give them the hours worked, so we'll say $8 an hour. And then we'll say the hours worked was, for example, 15.5, and that's the correct wage right there. And then finally, we can make sure that it works for fractions, for decimals on both hourly wage and hours worked. The way to do that, we have to give them a name. So we're going to call this person Jack. Then we give them an age, we'll say 40. And then we have an hourly wage. This time we'll say $8.50. And we'll say 11.5 hours. And you'll notice it still comes up the right answer. So with this, we know our program is actually working just as we intended. It's working perfectly. Everything's working right. But remember that we had to catch that little quirk of the scanner class to make sure it did that. However, at this time, everything's working correctly. But there are a couple of things that we can do before we finish up with this program. It's important to note that there's a couple of styles of programming that we haven't talked about. One of these styles, and I know I've had a couple of professors who felt this way, is that you have to declare every variable at the top. Now, if a person believed in this sort of style of programming, what they would make you do is say integer age, and then double hourly wage, and so on and so forth, for every single variable that we just ended up declaring here. Now, the reason some people do this is that it makes sure that when somebody's reading through your code, they can see all the variables at the top. And that way, you don't have to keep on putting in, you don't have to stick these keywords in there, and it doesn't look as ugly. The problem with this is it can be a little bit confusing, especially when we have very similar names, such as hourly wage and hours worked and hourly wage 2 versus hourly wage 1. When you're reading through the code, it can be quick. You can make a quick error and you can miss that part. So in my experience, I'm going to always do I'm going to always type them out like this, where we initialize right as we add in the values, but other people might do it differently. That shorthand, hopefully you know that already. You just say the type, in that case it was a double, and the variable name, and then a semicolon. You don't have to assign a value to it. In fact, you don't want to assign a value to it. It'll keep its default value, which for numbers is 0 or 0.0 in the case of a floating point. In addition, we haven't really talked about spacing. We touched on indentation a little bit, but with spacing of this type of program, it's actually fairly important. The way you want to space your programs is so that a single group of ideas is spaced together. So the idea that we're displaying something to the user would be together, and then all the associated variables with that display. So right here, we're displaying the age, hourly wage, hours worked, and name, and then all the variables with it are also grouped in right here. But ideally, and this is just to make everything look prettier and to function a little bit nicer when you're working with other people, you'd want to space out your double earnings, because the double earnings technically isn't being taken in from the user. It's a separate function. So we want to separate that out, and then we want to separate out the final print statement, since again, that's different to how we calculated the earnings. If you had multiple variables you needed to calculate the earnings, then they would all be stuck together, and then your print statement would be by itself. So spacing tends to be so that we separate out big ideas. First, we separate out the idea of each employee into its own space. Then we separate out each function inside the employee calculation into its own little space again. And we separate them with enters or returns every time. Now, this program actually works perfectly fine. So this is our first case study, and it works just as we intended. Hopefully you learned a lot in this lesson. We talked about our first case study, where we used a program to model 3 employees, where, as you can see up here, we took the input for name, age, hourly wage, and hours worked, and we outputted the earnings, names, and ages. You can start to put in these sorts of algorithms if you want to in the future for your own programs. I'm probably not going to, but if you want to, it's a good way to keep your stuff in check. And then we talked about the importing of 2 classes using a wildcard import. We talked about spacing. We talked about making sure our variables are separated out. And we talked about having separate variables for each display. Then we talked about print functions or print methods and how to add strings together, or how to add a string and an integer. Make sure we space those properly. We talked about the quirk of the scanner class, a very important quirk that normally would have caused us an error if we didn't catch it, where we have to say input.next after an input.double, where we're trying to take another bit of text, because otherwise it'll try to take the space and assign that to the string, and then try to assign the string that we type in to the integer, causing an error. And then we tested the program with various test data that was practical, and we tested all aspects of the program. We made sure that the ages and the names worked correctly, we made sure it worked for all 3 employees, and we made sure that it worked with integers for the hours worked and hourly wage, 1 integer and 1 decimal point value, and 2 decimal point values. Hopefully you found this lesson useful, and hopefully you'll join us for the next lesson, where we'll be doing another case study, this time modeling a rectangle.